in the test lab.
Well, I use math almost every day in my job, and we use it to calculate diets. It's quite an intricate job because a lot of animals have different sizes and different species, so their nutritional requirements are very different. So every animal at Toronto Zoo, or every species at Toronto Zoo, and actually every animal as well, because we have big ones and small ones within the same species, gets its own diet calculation. So we use that, and we do that mostly by computer. We look a lot in what the animal's been eating in the wild, and we try to copy that. And that's obviously not that simple, because a lot of these animals are from completely different places in the world than Toronto, Canada. So we use diet analysis. So we do nutrition analysis of diets, and we try to make diets with a similar analysis and with similar components. And a good example is the browse. This is browse over here, this is apple browse, and we feed that to gorillas. And gorillas really need this apple browse. We did quite a lot of research with that last year. The gorillas in the wild will never get apple browse, but in the Toronto Zoo they do, and they do very well on it. And this is a good example how we've copied, what's going on in the wild. Well, everything that happens at Toronto Zoo Nutrition Center is calculated. So salaries are calculated and food acquisitions are calculated. What Gino Lombardi, that's Gino Lombardi here, what he's packing here is we get amounts of produce about 3 times a week, and every time it comes it costs us between $1,800 to $2,000. We spend something like a little over $900,000 per year just on buying foodstuffs for the animals. I've done nutrition or animal nutrition for about 25 years in several parts of the world with a lot of different species, and to avoid mistakes you kind of have to develop a sixth sense. If your result, what you calculated, makes sense, and so somehow when you computer calculate you try to always do that more or less unconsciously in your head. So you have to know math very well if you want to do a job like I do. Well, I'm educated from the University of Groningen in the Netherlands, and then I worked for a while in several jobs, and then I did a further study at Aberdeen, Scotland, the University of Aberdeen, in a Masters of Animal Nutrition. And then I've worked as a Master of Animal Nutrition for at least 25 years in several areas, mainly research. So we've done a lot of statistical calculations, trying to find out the truth about certain things, and that's what you need statistics for. Try to calculate real averages and real means to find out what's really good and what's really not good for animals what we're feeding right now. We do a lot of work which is high profile. There's some polar bear research going on in which we use a lot of math. We have a little polar bear baby who is growing up, and we want to follow his nutrition intake very well, and all we do that with is math. The problem is, if he eats too much, he might develop what we call metabolic bone disease. So he get bent legs, or he get very sore growth plates on his legs, and he'll get very, very sick. So if you don't feed him enough, he will not develop as he should develop. So it's a trick to calculate what we need to give him, and we weigh him. Again, with math, we weigh him every week, and we do change his diet accordingly how much he has been growing. If he grows a little bit, we give him some more food. If he grows very much, we reduce his feed intake. Now, the big thing about Hudson, our polar bear, is that he will give us data which are kind of unprecedented data, which people who are working with polar bears in the wild, in the Arctic, they're really keen to have those data, because they do not know how fast young polar bears grow. They do not know how much energy a little polar bear requires, and obviously that's essential information for their future survival.